Hi guys, welcome back to another video. I've done a previous video on configuring OSPF in Area 0 between router R1 and router R2. This video is further configuration on OSPF, specifically configuring R1 to be an ASBR and R2 to be an ABR, and creating Area 1 and then configuring Area 1 to be a stub and a totally stubby area. As part of this, we will also create and add R3 to Area 1. So parts of this diagram has already been configured. Routers R1 and R2 were configured in Area 0 with OSPF turned on. I changed this IP address here in the middle to be in the 10 network here. It used to be in the previous video, it was in the 172 network. The reason I did this because Area 0 can be all in the 10 range, in the 10 network, and then Area 1 can be in the 172 space here, including the loopbacks, and then the external redistributed routes can be in the 192 space here. It's just easier to see things this way, and it's easier to troubleshoot if we have any issues. So we've got the tasks. Task 1 is here, turn router R1 into an ASBR, this one here. And then task 2, turn router R2 into an ABR. So router 2, this will be an ABR between Area 0 and Area 1. The third task will be to turn Area 1 into a stub area, and then the fourth task will be to turn Area 1 into a totally stubby area. The first thing we will do is jump onto R1 here and R2 and have a look at the routing tables. There is no R3. So here we go, R1 and R2. Let's log in and have a look at the routing tables. Show IP route. And what we see is the OSPF routes. These are the ones that are configured on R2. These are the loopback interfaces. Let's have a look at R2. Again, show IP route, and again we see some OSPF routes advertised. These are the interface loopbacks on R1. We can put them side by side and we can run a show IP interface brief, and we can have a look at the loopback interfaces. Show IP interface brief, and we can see the loopback interfaces here. So these loopback interfaces are being advertised over OSPF at the minute. But also what we can do is look at the current LSA types. There's only LSA Type 1 and Type 2 at the minute, but if we run a show IP OSPF database, we can see the Type 1 LSAs, which is the router link, and we can see the Type 2 LSAs as well, which is the network link. These are the link IDs and these are the advertising routers. But we can drill into these as well. So if we do a show IP OSPF database question mark, we can see the different LSA types. So we will have a look at the Type 1 router. If we do router here, and then we see the advertising router here and all of its links. So we see the loopback interface here, and we see the other one here. And then if we press spacebar again, we can see the rest of it. So we can see the transit network. This is the network between the two routers. We can see the IP address and it's the designated router. We also see from the perspective of the other router R2, and we see the same sort of thing here as well. The stub network, by the way, means that there is no OSPF speaking router on that network segment. And we can have a look at the Type 2 LSAs. So let's go with network here, and what we see is we see the LSA type, which is the network links. We can see the advertising subnet. We can see the subnet. It's the designated router, which makes sense because the DR is the one that generates the Type 2 LSAs. We can see the advertising router here, so it's R2, and we can see the attached routers to this designated router, which is R1 and R2, and we see the prefix as well, which is /30 for this network. Right, let's start to configure R2, the interface for R2, what we can see here. So we will configure this interface on this side, and then we will create this new router and configure the interfaces as well on the new router. So the .2 interface here and the loopback interfaces here as well. And we can already see that fast Ethernet 01 is unassigned, so this is the interface we will configure. So let's jump into configuration mode, int FA 01, no shut, and give it an IP address, which will be 172.16.50.1, and it will be a /30, which is a 252, and that's our one done. Let's do show IP interface brief, and now we can see the fast Ethernet 0/1 interface is configured. The protocol is down because the other side is not configured yet, but we will do that now. Let's bring R3 into the picture. So let's go to network devices here. Let's drag this router above here into the workspace. Let's give it a connection. So let's click on connections here, this straight through cable here. And let's go with the Fast Ethernet 01 on R2. And let's connect it to Fast Ethernet 00 on R3. And let's change the name to R3. And now let's configure R3. So go to CLI, let's say no to the initial configuration dialog, and let's go into configuration mode and let's give it a host name of R3. Let's do a do show IP interface brief, and we can see the Fast Ethernet 00 is unassigned, so we will configure that next. Interface FA00, IP address 172.16.50.2 on a /30 network, which is 252 at the end. And let's bring the interface up. And let's configure our loopback interfaces as well. LO0, and let's give it an IP address, which is 172.16.0.1 on a 24 prefix network space. And what else I want to do is run IP OSPF network ? And point to point. So I want to make it point to point, and the reason for this is so it doesn't advertise them with a /32 prefix. So we've just configured it as a /24 prefix, but Cisco autocorrects it and changes it to a /32 prefix. We don't want that. It does that by default. It automatically does that. But if you change it to a point to point network, Cisco accepts the prefix we give it, so it doesn't automatically change it into a /32. It does this because it thinks it should be a /32. It thinks it's a loopback address. It should be a /32. It shouldn't be on a /24. It shouldn't be part of a subnet. So this is a good way to get around it for lab and testing purposes. Let's configure loopback 1. IP address 172.16.1.0 on a /24 as well. And do the IP OSPF network point to point. And our IP addresses are configured, so let's do a show IP interface brief, and we can see everything is up. Fast Ethernet 00 IP address and everything is up here, and we can see our loopbacks here as well, and they're all up. Let's do show IP protocol. Nothing should be running. Let's do a do show CDP neighbor. We should see the one neighbor on Fast Ethernet 00. We can see the remote end is C2800 on the interface Fast Ethernet 01. Let's go on R2 first. Let's do a do show CDP neighbor from here, and we can see both routers are attached to R1 to R2. So we can see R1 here and we can see R3 here. Router OSPF 1 network 172.16.50.0 and the wildcard mask of 000.3. And this will be in area 1. And let's do the same for the loopback interfaces as well. Let's change this to 255 and let's change that to a 0, and then let's change that to a 1, and both loopback interfaces are in there as well. Let's do a do show IP OSPF, and now we can confirm it's an area border router or router, and we can confirm that there are 3 interfaces in area 0, and let's look at area 1, and we can see that there's 1 interface in area 1. But I've made a mistake. Those loopback interfaces should be advertised from router 3 perspective. Let me do a do show IP protocol, and we can see that these loopback interfaces shouldn't be here. They should be on router 3. So let's just do a no on that. 172.16.00 0.0.0.255 area 1, and let's do the same for 1.0 as well. Do show IP protocol, That looks better. Let's jump on to R3 and configure R3. Router OSPF process ID of 1. We need to give it a router ID as well, so router ID 3.3.3.3. And let's advertise our networks into OSPF. So network 172.16.50.0 and this is 0.0.0.3, which is a 252. It's a wildcard mask. In area 1, let's advertise our loopback addresses. That would be network 172.16. And we can see the OSPF neighbor relationship has come up. 0.0 and a wildcard mask of 0.0.0.255 in area 1. And let's do the same for 1.0 as well. And the first command I would like to run is the do show IP OSPF neighbor. Just to confirm I can see the neighbor. It's telling me that that neighbor is the DR. It's built a full relationship with it on fast Ethernet 00. So I should see two of these from an R2 perspective. Do show IP OSPF neighbor. And now we can see R2 has both of these neighbors, R1 and R3. But more importantly, let's do a show IP route from an R1 perspective. So from this diagram, from R1, we should be able to see these loopback subnets now advertised into R1. And we should see them with a /24 prefix. Because in the first video, even though I configured my loopback addresses on this router here and on this router with a /24, they were advertised with a /32. That's because I never did the IP OSPF network point-to-point on those loopbacks. So this time it should advertise them correctly with the /24. So we'll jump onto R1 now and see if we can see these loopback addresses. Let's run a show IP route. And here they are. I can see both loopback interfaces. So this is R1 on the diagram here. This is R1 and it's these two loopback interfaces that have been advertised into R1. And the way you can also tell their OSPF routes is via the O here, and the IA stands for inter area, so routes from another area. If you ever wanted to know what the codes are, just have a look here, the codes, and it will give you the codes in here. So IA is here, OSPF inter area. Also, let's look at the LSA database, because now we should be able to see the summary routes from the ABR. So let's do a show IP OSPF database. Let's do a question mark here. And let's have a look at the bottom one, the summary. So let's type summary and have a look in here. There should be lots of links and we should see the summary network as well here. So we can see the ABR is advertising this network. That's one of the loopback interfaces. We can also see the transit interface here as well. If we do a spacebar, we should be able to see the other loopback interface, which is here. And there's quite a few other OSPF verification commands, like the show IP protocol is my famous one, and the show IP OSPF neighbor, also show IP OSPF. You can also do a show IP OSPF interface, gives you a bit more specific interface details, the OSPF details on the interfaces themselves, and there's a few more as well. Next, what we will do is make the router 1 an ASBR, so we can do route redistribution, which is importing external routes into the OSPF domain. So let's do that next. But the first thing we will do to do that, we will create a router that will imitate the cloud. So let's minimize these and let's add another router on the left hand side here, and let's connect this on its fast Ethernet 00. Let's click on connections first and the connection here, and then let's connect it to a spare one on here, which is fast Ethernet 01. Now let's configure the cloud router. Let's give it a name of cloud, and let's configure the router with a host name. Let's do no here, en conf t hostname cloud, and let's configure the FA00 interface. IP address 192.168.50.2 255.255.255.252, and let's do a no shut, and the interface is up, so the cloud is configured. Let's go to router 1. On router 1, let's configure the interface as well. Interface FA01, IP address 192.168.50.1 on a 255.255.255.252, and do a no shut. And the status has changed to up, and we can see that with the green lights in Packet Tracer as well. Now the next thing we will do is, if we have a look at the diagram again, we can see these external networks. We need to do some routing. We need to put these static routes into R1's routing table. So the 192.168.0 and 5, we need to put them as static routes into R1's routing table. So let's jump onto R1 and do that next. IP route 192.168.00 255.255.255.0, and the next hop will be 192.168.50.2, and the same for .5 as well. So we've added the static routes. Let's have a look at the routing table. Show IP route, and we can see the static routes here now. Right, let's redistribute them into OSPF. So let's go into router OSPF 1, and if we do a redistribute static, do a question mark after it, we can put metric in, an initial metric. The default is 20. We can also add a metric type of metric 1 or 2. So with 1 the cost is added as it transits through the routers, and with 2 it stays the same. And with the subnets keyword here, it ensures it just doesn't use classful boundaries, so it's good to use this keyword. So let's put subnet in and hit enter, and that's it. Route redistribution is done on R1. So what we will do next is confirm that it's working by going to the diagram and having a look here. So the R3 should be able to see these networks down here that have been redistributed into OSPF and have gone through area 0 and right into area 1 on R3 over here. So let's go to the R3 routing table, show IP route, and there we go. So we see OSPF, O for OSPF, E for external type 2, and we see both static routes in the R3 routing table. So our route redistribution is working perfectly fine, and actually this was task 1 here. Turn router R1 into an ASBR. The second task is to turn router 2 into an ABR. We've already done that actually. The way we turn router 2 into an ABR is by connecting it to R3 in area 1. It was already part of area 0, and then we confirmed it by running the show IP OSPF, and it showed in there that it's now an ABR. As well as the LSA Type 3s, which the router 2 is dishing out, which is the job of the ABR. So the final 2 tasks is task 3 to turn area 1 into a stub area, and task 4 to turn area 1 into a totally stubby area. So let's do task 3. I'm talking about LSA types. If we jump onto R3 again, we should be able to see the type 5 LSAs as well. So if we run the show IP OSPF database, do question mark, and the type 5 LSAs is the external ones here. So let's do an ext here, and here we go. We can see the type 5 LSAs. And what this is showing us, it's showing us the network 192.168.0.0 and the advertising router, which is 1.1.1.1, and we can see the prefix as well, which is a /24. And we can see the exact same thing for the 192.168.5.0 as well. Now let's turn area 1 into a stub area. A stub area blocks type 4 and type 5 LSAs, and the ABR provides a default route into the area instead. And for this we will configure the R2 and R3 with the stub area command, so area 1 becomes a stub area. So whilst we're on R3, let's do R3 first. Let's do an IP route just to confirm that the external routes exist. And we can see the external routes here. So once this is a stub area, these external routes will disappear and they will be replaced by a default route. That's what stub area does. If you watch my previous video on the different types of LSAs and the special areas, it will explain what stub and totally stubby areas are, as well as not so stubby areas as well, and all of the LSA types as well. So to configure R3 as a stub, let's go into router OSPF 1. Let's do conf t and then router OSPF 1 and do an area 1 stub. And that's it, it's a stub area. The neighbour relationship has gone down with R3, and that's because they all need to be a stub. Otherwise the relationship goes down if one's a stub and one isn't a stub. They all need to be stubs in the stub area. So we will do the same on R2 now. You can see the neighbour relationship has gone down. Let's do a show IP route first. We can see the static routes in here, and then let's do a router OSPF 1 conf t router OSPF 1 area 1 stub, and the relationship should come back up. And there you go, the relationship has come back up. You can see it's come back up with 3.3.3.3, which is R3. And let's jump back onto R3 to confirm the routing table, and that is now a stub area. So let's do show IP route, and we can see that the static routes have disappeared and have been replaced by the OSPF inter area default route over here. I think the star means that it's a stub. And the whole point of a stub area is because if there is only one exit point, there's no point of having these static routes. Why not just go via the default route? Now if you watch my previous video, I explained what a stub area is, as well as a totally stubby area and a not so stubby area. I also explained the different LSA types as well, type 1 to type 7. So a stub area blocks type 4 and type 5 LSAs, but a totally stubby area blocks type 3 LSAs as well, because it's already blocking type 4 and type 5 LSAs and it's already got a default route. There's no point having type 3 LSAs as well from the ABR, telling you how to get to other areas when the only thing it needs is the default gateway, because it's only got one exit point anyway. That's the whole point of a stub area. So let's make it a totally stub area and block type 3, type 4 and type 5 LSAs, as they're not needed since we have this default route. Now let's make area 1 a totally stubby area by issuing the no summary command on R2. So it's only done on R2, it doesn't need to be done on R3. And what this will mean, all of these inter-area summary routes here issued by the ABR will all disappear as well. As we don't need them, we've got this default route here. If you can see, all of the exit points, the gateway is the same, 172.16.50.1, and the default route has the same gateway, 172.16.50.1, which is via R2, the ABR. So let's go to R2, area 1. Let me just exit out of here and start again. So let's go to router OSPF 1, and then it's area 1 stub no summary, and that's it. Hopefully these inter area routes should all disappear now. So let's do a show IP route again. Do show IP route, and there we go. The type 3, 4 and 5 routes have all disappeared and they have been replaced by the single default route over here.